In 1610, the great astronomer Galileo Galilei peered through his telescope and made a discovery that would change our understanding of the universe. He observed 4 bright objects orbiting Jupiter. One of them was Europa. But it would take centuries before we realized just how extraordinary this tiny moon truly is. Europa is one of Jupiter's 4 Galilean moons, along with Io, Ganymede, and Callisto. It is slightly smaller than Earth's moon, but its icy surface hides a vast ocean beneath. Over time, missions like Voyager, Galileo, and Hubble provided crucial insights into Europa's mysteries. In 1979, NASA's Voyager spacecraft flew past Europa, capturing stunning images of its smooth, icy surface. Unlike other moons, Europa had very few craters, suggesting a young, active surface. Scientists noticed strange dark streaks and cracks running across the moon, hinting at hidden forces beneath the ice. In the 1990s, NASA's Galileo spacecraft provided high-resolution images of Europa. It detected a weak magnetic field, suggesting a global ocean beneath the ice. The mission revealed that Europa's surface is constantly shifting, possibly due to water movement below. For the first time, scientists had real evidence that Europa wasn't just a frozen wasteland. It was an active world, with the potential to harbor life beneath its icy crust. But what exactly is happening beneath its surface? And how does Jupiter's immense gravity shape this fascinating moon? Europa is not just another moon. Its structure makes it one of the most unique places in the solar system. Beneath its icy shell, scientists believe there is an enormous ocean, possibly holding twice the amount of water as all of Earth's oceans combined. But how is this possible? And what does this tell us about Europa's potential for life? Europa's structure isn't just scientifically fascinating. It could be a crucial clue in the search for extraterrestrial life. Could its deep ocean be teeming with unknown organisms? And if so, how could we ever explore it? For decades, scientists have speculated about what lies beneath Europa's thick, icy crust. But today, we know with near certainty that an immense ocean hides below the frozen surface. An ocean that might just be the most promising place to find alien life in our solar system. But how do we know it exists and what could be hiding? How do we know Europa has an ocean? NASA's Galileo spacecraft detected a fluctuating magnetic field, indicating a conductive liquid, like salt water, beneath the ice. The dark streaks and chaotic terrain suggest the ice is shifting due to subsurface water movement. In 2012, the Hubble Space Telescope detected water plumes erupting from Europa's surface, evidence that liquid water exists beneath the ice. How deep is Europa's ocean? Scientists estimate the ocean could be 100 kilometers, 62 miles, deep, far deeper than Earth's oceans. If true, this means Europa holds twice as much liquid water as Earth. The ocean is kept liquid by Jupiter's immense gravitational pull, which causes Europa's interior to heat up. Could life exist in Europa's ocean? On Earth, deep-sea hydrothermal vents host entire ecosystems without sunlight. If similar vents exist on Europa's ocean floor, life may have evolved in complete darkness. Microbial life forms, or even complex organisms could be thriving beneath the ice. The next step, how can we explore Europa's ocean? Future missions aim to drill through the ice using robotic submarines. NASA's Europa Clipper mission will fly through Europa's water plumes, searching for signs of life. Could an advanced probe one day swim through Europa's alien ocean? If Europa's ocean harbors life, it will be the greatest discovery in human history. Could we be on the verge of proving that Earth isn't the only home for living organisms? And what challenges lie ahead in the search for life? Europa is one of the most promising places in the solar system to find alien life. But how can we know for sure? Scientists have already uncovered intriguing evidence that suggests Europa's ocean might not be lifeless. Could we be on the verge of the most groundbreaking discovery in human history? The ingredients for life on Europa include water, as Europa's ocean holds twice as much water as Earth, making it one of the most habitable environments beyond our planet. An energy source is provided by tidal forces from Jupiter, which generate internal heat, keeping the ocean liquid and possibly fueling hydrothermal vents. Essential chemicals such as oxygen, hydrogen, and carbon dioxide have been observed, which are key elements for life. Evidence that Europa could host life includes Hubble's discovery of water plumes. In 2012, the Hubble Space Telescope detected massive plumes of water vapor erupting from Europa's surface. Could these plumes contain organic material? The oxygen-rich surface is another factor. Radiation from Jupiter splits water molecules into oxygen, which then sinks into Europa's ocean, possibly fueling alien ecosystems. Additionally, Galileo's magnetic field data shows that NASA's Galileo spacecraft detected electrical currents in Europa's ocean, hinting at a salty, life-sustaining environment. What would life on Europa look like? It could include microbial life, with single-celled organisms thriving near hydrothermal vents, deep-sea creatures similar to Earth's two worms living in total darkness, and unknown alien biology, as Europa's unique conditions might have led to completely new forms of life. What's next in the search for life on Europa? The Europa Clipper mission will fly through water plumes to detect organic compounds. Future missions may drill through the ice to explore the ocean directly. Could AI-powered submarines one day explore the deep alien waters of Europa? The search for life on Europa has just begun. But if we find even the smallest microbe in its vast ocean, it would change our understanding of life in the universe forever. Could this frozen moon be the first place where humanity finally finds proof that we are not alone? One of the most exciting discoveries about Europa in recent years is the detection of water plumes erupting from beneath its icy crust. These massive geysers could give us a direct sample of Europa's hidden ocean without having to drill through miles of ice. But how were they discovered, and what secrets might they hold? In 2012, NASA's Hubble Space Telescope detected water vapor spewing from Europa's surface. These plumes rise up to 125 miles, 200 kilometers, above the moon's surface before falling back as ice. Later observations by Galileo and Cassini missions supported the existence of these geysers. The water plumes may contain organic molecules, key ingredients for life. They confirmed that Europa's subsurface ocean is actively interacting with the surface. Could hydrothermal vents on the ocean floor be fueling the plumes, just like deep-sea vents on Earth? The upcoming Europa Clipper mission will fly directly through the plumes to analyze their chemical makeup. Scientists hope to detect biosignatures, potential signs of microbial life. If life exists in Europa's ocean, we might not have to land, we could discover it in the plumes. If the plumes contain organic molecules or even microbes, it would be the biggest discovery in history. Similar environments on Earth's ocean floor support life without sunlight. Could Europa be the same? What challenges do scientists face in confirming life from these samples? Europa's plumes could be the gateway to one of the greatest discoveries of all time, the confirmation that life exists beyond Earth. For years, scientists have dreamed of exploring Europa's vast, hidden ocean. Now that dream is becoming a reality. NASA's Europa Clipper mission is set to launch in the next few years, bringing us closer than ever to unlocking the secrets of this mysterious moon. But how will this mission work? What are scientists hoping to find? The Europa Clipper is a state-of-the-art spacecraft designed to study Europa's surface, atmosphere, and subsurface ocean. It will orbit Jupiter and perform dozens of close flybys of Europa to collect critical data. The mission's goal is to determine if Europa has the right conditions to support life. High-resolution cameras will capture detailed images of Europa's icy surface. Spectrometers will analyze water vapor in Europa's plumes for organic molecules. Ice-penetrating radar will scan beneath the surface to detect hidden lakes or pockets of water. Magnetometers will measure the strength of Europa's magnetic field to confirm the ocean's depth and salinity. The Europa Clipper will launch aboard a SpaceX Falcon Heavy rocket, or NASA's SLS rocket. It will take several years to reach Jupiter, where it will use the planet's gravity to slingshot into orbit. The spacecraft will perform 50-plus flybys of Europa, collecting more data than any previous mission. If biosignatures, chemical signs of life, are detected in Europa's plumes, it could be the biggest discovery in human history. If evidence of hydrothermal vents is found, it would increase the chances of microbial life in Europa's ocean. The data could help pave the way for a future Europa lander mission, bringing us one step closer to exploring the moon's hidden ocean firsthand. With every new mission, we get closer to answering one of humanity's greatest questions. Are we alone? Could Europa's ocean be home to alien life? The Europa Clipper is our best chance yet to find out. But if life does exist, what would it look like? And how would it change our understanding of the universe? For decades, scientists have wondered, could Europa's vast, hidden ocean be home to alien life? The conditions beneath the ice seem eerily similar to places on Earth where life thrives. Could we be on the verge of discovering our first extraterrestrial neighbors? Let's explore the most compelling theories. The most likely possibility is simple bacteria-like organisms living near hydrothermal vents. If life has evolved for billions of years, Europa could host alien fish-like organisms. Europa's unique environment might give rise to completely new forms of life. In Earth's deep oceans, hydrothermal vents support thriving ecosystems without sunlight. Bacteria near these vents use chemical energy instead of sunlight, a process called chemosynthesis. If Europa has underwater volcanoes or vents, life may have adapted in a similar way. The Europa Clipper mission will look for biosignatures, chemical signs of life. Future missions could send submersible robots to dive into Europa's ocean. If alien life exists, how would we communicate with it? What if it's intelligent? If life exists on Europa, it would be the greatest discovery in human history. But if we find life there, it raises even bigger questions. Is life common throughout the universe? And if so, what else is out there? Europa has fascinated scientists, dreamers, and explorers for decades. We now know that beneath its icy shell lies an ocean that could be one of the best places in the solar system to find alien life. But even with all the discoveries we've made, many mysteries remain unsolved. What are the biggest unanswered questions about Europa, and how close are we to finding the truth? Is there life in Europa's ocean? Scientists believe microbial life is possible, but we still need direct evidence. How thick is Europa's ice shell? Some estimates say 10 kilometers, others say 30 kilometers, a big difference when planning missions. What powers Europa's water plumes? Are they from deep hydrothermal vents, or is there another unknown force at play? Could Europa's ocean support complex life? If so, does that mean life is common in the universe? The Europa Clipper mission will provide our best data yet, but won't land on the surface. A future lander mission could drill into the ice and search for life directly. Scientists dream of a robotic submarine that could explore Europa's deep ocean in real time. Would it change our understanding of biology? Life on Earth may not be unique. Would we need new space laws? How do we protect alien ecosystems? Would it prove that life is common in the universe? If it happened twice here, it could be everywhere. Europa represents one of the greatest scientific frontiers of our time. The search for life beneath its icy surface may redefine everything we know about the universe. But in the end, the biggest question remains, are we truly alone? Or is Europa just the beginning of something much bigger?